basic definition of probability, and we have also solved some problems on probability. Today we are going to mainly concentrate on random variables and lead it to probability distributions. Use of probability in practical life is basically through probability distribution. Generally we don't use probability only to find probability of, like examples what we did last time on cards or balls or coin. This is something to understand the probability, we use those problems. But practically there will be experiments which will be done, and now we want to decide whether the method used or the process used is good or not, or is valid or not. And for that there is a statistical process or a probabilistic approach which will be used in, which says that this method is good, is probabilistically accepted only if it satisfies few of the rules. Now for that we need to know what are those aspects of probability where we have number of data items. Data is something which is collected information or a quantified information from an experiment. Now if everything which deals with the collection, processing, analysis and interpretation or inference from that numerical data will be useful in our practical application or usage of a particular process which we want to adopt or which we don't want to adopt. So for that, the first thing what we need basically is a variable. Variable is something which says that its value changes. So in general mathematics we use variable and constant. So constants are the ones whose value is fixed, and variables are those whose values change. Now why we have attached the word random? Like we have seen in probability process that it must be a equally likely kind of event. So we want the process to be random. That means there must be a random choice of or a random processes, assuming that every outcome is equally likely. So randomness basically gives that kind of an approach that equally likely outputs will be put in. So a random variable, generally written as x, is a variable which will have values which are outcomes of values which are outcomes of random processes. And as I am saying values, I basically mean it's a quantified output. We don't want things like good or bad or less or more. These qualitative output is not what is looked for, but a quantitative output, and hence a random value, random variable will have a value which is associated as an outcome of a random process. Now there are two types of random variables which we have. One is discrete and one is continuous. Let's first understand what is a discrete random variable. Discrete random variable is the one which takes generally finite or countable number of values. Discrete random variable is the one which takes countable number of values, and continuous is the one which takes or which can take infinite number of values. So the examples here are discrete random variable which is countable, like number of bulbs. We can count, though there could be many, but we can say 1, 2, 3, 4, 5 like this. But if we say height here, now we are not going to say somebody's height is exactly 5 feet, or we cannot say it is 5 feet 3 inches, it could be anything in between. So height, weight, kilometers, all these kind of things would take continuous values, means they can take every in between value, whereas when we look at numbers or a countable thing which is like number of bulbs, number of balls or number of coins, all these will be discrete random variables. Now depending on whether the variable is discrete or continuous, it will have a set of data. Now what those data items would be, let's concentrate more on a discrete random